Okay, something happened. I don't know what happened. So, square root of 40 is the same thing as the square root of 4 times the square root of 10. Square root of 4, I picked that because it is a perfect square, so that gives me 2. And square root of 10 has nothing, so it's 2 radical 10. The problem with that is that maybe you don't recognize 4 and 10, but you instead see that the square root of 5 and the square root of 8. Now, those multiply together to give you the square root of 40. But you might not see that there's still a perfect square in here, because this breaks down to the square root of 4 times the square root of 2. The square root of 4 is a perfect one, so that is 2. Multiply this stuff back, and it gives you 10. In the long run, the prime factorization method is the way that I'm going to be going. Okay, so when you simplify, if you have something like 6 radical 24, well, the 24 has to be simplified. So I'm going to, off to the side, I'm going to figure out what 24 is. So 24 is 3 times 8. And I know 3 is 2, or excuse me, 8 is 2 times 2 times 2, which gives me 2 radical 6. One number from each pair, and then multiply the garbage left and throw it back underneath there. This, if you remember, equals the square root of 24. So the square root of 24 equals 2 radical 6. So if I want to take the time, you need to recognize that this is the same thing as 6 times 2 radical 6. Both of these numbers are outside the radical, so I can write that as 12 radical 6. The reason why I relate it to fractions is because if you have 2/3, say, times 5/7, you multiply numerator times the numerator, gives you a new numerator. Denominator times denominator gives you a new number in the denominator. We will get to more of multiplying, but if you have 3 radical 5 times 2 radical, let's say 7, number outside times number outside gives you a new number outside. Number under times the number under gives you a new number under. But whether you are adding or subtracting or multiplying, you always have to check to make sure that, hey, there aren't any perfect squares hidden in the numbers that you just multiplied together. So square root of 35 gives me 5 times 7, no pairs, so this would be my simplified answer. Okay, let's do a couple more problems. We are going to start talking a little bit about, actually we'll just do some more simplifying. If we have 2 radical 5 times 3 radical 5. outside, new number outside gives me a 6. That gives me times the square root of 25. But the square root of 25 is 5. So what is 6 times 5? And you should have gotten 30. When you are simplifying with division, actually we will do square root of the fraction 25 over 64. Notice that the whole fraction is underneath the radical. That is the same thing as splitting it into 2. The square root of 25 over the square root of 64. Square root of 25 is 5. Square root of 64 is 8. My answer is 5/8. So just like if we have it written as 1, we can pull it apart. Or if we have it apart, we can make it 1. And I can simplify under, which gives me the square root of 1/4. And I could pull it apart again if I wanted to. Gives me 1/2. And I could have done that over here and gotten 2/4, which still would have given me 1/2. Okay, nice thing about radicals is a lot of times, as long as you're not breaking any math rules, it's not going to really matter what you do first. So that is some of the properties of simplifying radicals.